Hi, this is Richelle Tuvillo, and in this video I will present my report about correspondence analysis. That's our topic under our subject in educational research. That's EDRE 361, Advanced Data Analysis. This CA is an exploratory multivariate data analysis technique that utilizes qualitative variables, and usually our visual output is a geometrical plot. Okay, so let's start with the discussion. Okay, so these are the videos now. Before I demonstrate CA in the three statistical software, I will give a brief background and statistical concepts of CA. I will be focusing more on simple CA in this video. I was inspired by the following statement taken from the website of statlife.org. It tells us the importance of why we need to recall the past. Okay, so according to Confucius, study the past if you would define the future. And the further back you can look, the further forward you are likely to see. That's from Churchill. Here's a brief history of CA. Hirschfeld and Fisher were the first to study about CA in 1935 and 1940. This was taken from the Book of Greenacre, followed by Gottman in 1942, Hayashi in 1950, Binzikri in 1960, Nishizato's dual scaling in 1980, and Greenacre published his book in 1984. The statistical programming language R was released in 1993. And Husson's FactorMineR was published last 2014. Okay, when to use CA, what type of variables are necessary? But before I answer that question, I will be showing you a hierarchical tree. Here is a hierarchical tree illustrating the links between the principal methods of data analysis. As a multivariate data analysis, there are two types: the principal component method and the clustering. The previous reporters discussed the hierarchical clustering, both agglomerative and divisive, while the other one considers the k-means under partitioning. I'll try to make a video of those methods if I have time. On the other hand, my simple CA together with multiple CA and PCA, or we call this the principal component analysis, are under one-way method, while multi-factor analysis, etc., were considered as a multi-way method. Here's a brief comparison of the different multivariate data analysis techniques. My simple correspondence analysis uses two qualitative or categorical variables, but multiple CA requires three or more qualitative variables. Both are exploratory as opposed to canonical CA and regression or ANCOVA, that is decisional. Or there should be a dependent variable and an explanatory variable. Simple CA is different from principal component analysis, wherein the latter requires quantitative or numeric variables, which considers all the variances in the data. Similar to PCA, factor analysis also requires quantitative variables but considers only the covariance between variables. Multiple factor analysis may analyze qualitative and or quantitative variables. And the last, the cluster analysis requires quantitative variables only. According to F. Huson, the term correspondence analysis stems from the fact that tables are analyzed by linking two corresponding sets, that which is represented by the rows and that represented by the columns. They have symmetrical rows. Another description of CA comes from NCSS statistical software is that the correspondence analysis is a technique for graphically displaying a two-way table by calculating coordinates representing its rows and columns. These coordinates are analogous to factors in a principal component analysis used for continuous data, except that they partition the chi-square value used in testing independence instead of the total variance. So most of the time I will be talking about rows and columns, two-way tables such as contingency tables, chi-squares, and graphical displays. To understand more about this definition, let's run a CA using my phys-ed dataset. I can use the prepared dataset from the book of F. Huson and B. Anastasi, but the topics were all about psychology, sociology, wines, Olympic gold medals, sales, and marketing. Thus, I decided to make my hypothetical dataset related to my field. I customized my dataset that it will be more related to my possible dissertation in the field of physics education research. Now, to give you a background of the dataset Physics Ed, let's start with the following. Okay, we have here a research was conducted to 100 grade 10 students composed of 3 sections, namely section A, B, and C. They were given a 180-item pre-test and post-test in physics and astronomy after they had attended a series of after-school activities such as physics, team building games, and astronomy camps. It also includes a questionnaire asking them about their intended academic strength for their senior high school, their favorite subject. Let's see here. Okay, so we have 3 strands: gas, fumes, STEM. Gas stands for general academic strand, humanities and social sciences for the humes, and science, technology, engineering, and mathematics for STEM. For the later we will be using these favorite subjects and college courses. Their GPA in science was retrieved together with their IQ score. Now, before I'm going to demonstrate, these are the possible questions that we can ask in this type of research. Is there an association between the students' class section in junior high school and in their senior high school academic strand? And later in my MCA, or the multiple correspondence analysis, we have this question: if there is an association between the favorite subject in high school and college course to take. Now let's start with the demo. Have the next video.